Hi everyone. So we are going to start the session now about offline development and performance improvement. Now, this session is a bit technical and meant for developers with some experience in RIA programming. So we are assuming you know what is RIA, client server, and so on. And if you have any question, feel free to ask me in the chat dialogue, so I will respond to it. Okay, before we start describing how offline is used in Magic applications, let's talk about the goals of offline applications. So the main goal is in offline is to allow the user to work on the system or parts of it when the network is not available. And a side effect of this goal is actually to improve the performance, since there is no action to the server and you don't need to download a lot of data each time. So this is the main goal of offline. Now, using an offline application has some challenges, and the main one of them is that you don't have any network, so the network can be intermediate network or slow network or disconnect in time to time, and you need to handle those issues. So this is one thing that you need to handle in your application. The other one is data. You don't have the server data, so you need to store the subset of the server data on the client machine, and also to allow new data entry on the client, and of course handle the synchronization between the server and the data. New data is entered on the client side, needs to be copied to the server, and vice versa. Now, the last thing you need to do for handling offline application is to have all the metadata, and by metadata I mean all the application metadata, such as menus, font file, core files, and so on, and also your metadata, such as images. They need to be available for the client on the client machine. So this is something else you need to handle, and some of this is handled automatically by the engine, and we are going to discuss all of those issues. Now, the offline application pattern is actually a bit different than online application, since because there is no server, the client needs to work on its own. So this needs to be handled. So the execution flow is as follows. On the first execution of the application, all the necessary resources are required for offline application, such as the metadata and images and so on. They should be synced to the client. Now, this means that the application must be first started with a connection to the server. You cannot start an offline application without the first connection. And of course, from that point onwards, all the user interaction must be done using local resources, using local data, local images, and so on. Now, by using local resources exclusively, the application is guaranteed to work regardless of the internet connection. Okay, so even if you don't have server access, the application will work because it doesn't have to access the server side. Now, regarding data synchronization, this can be done automatically on startup. You can define it in start program to call the synchronization program, or by the user whenever you want. Now, we are going to discuss the synchronization later on, but basically the concept is to just sync only the modified records and not all the database each time in order to reduce the performance time. And of course, you're going to synchronize all the metadata objects, like any change you did in one of your programs also need to be synchronized. This would be done automatically, as you're going to see later on. So let's talk about all the resources and how they are going to be cached by the application and by the engine. So first of all, offline program definition. An offline program is defined in the program properties. There is a checkbox named offline. I will show it later on. You can also see the offline programs in your program repository. And offline programs has a distinctive characteristic that it doesn't access the server at all. This means that it is downloaded to the client on startup when the application is started. All the offline programs are copied to the client automatically by the engine. And if you have offline programs in components, then those components should be marked as load immediately, so that the engine will copy them to the client also. And all access to any offline program is done via the cache. So you will not contact the server in order to download the metadata of a program. Now, offline program has some limitations. We are going to discuss them later on and how to overcome them. Next thing about that application require, as we mentioned, is all the metadata, the environment metadata, such as ini settings, logical names, color and font files, and so on. And the application metadata, which is the main program menus and all the other things defined in the program themselves. So those are also automatically cached into the client side. You don't need to do anything about them. So on first execution, the client gets from the server anything that he needs to do to use later on in the execution of your application. And the last thing, which is important, is all the authentication. If you use the logon function, then this username and all of his rights are also stored locally, of course, encrypted. So if the next time you run the application and there is no server access, then the last user logged onto the system on this device will actually still have the same rights and authorization keys. And of course, you can clear this and not use this mechanism if you want to. Now, there are some things that you as a developer need to handle. First of all the images and your resources. We are not really know where your images reside. So for any image that you use in your application, you need to download them to the client cache. And the best way to do it is using the server file to client function. And we are going to discuss it later on also. Now, another alternative to download images is to use them in a non-offline program. So there is a call to this program, and then the files are already in the cache. But this is not really recommended. The best way is to use, as I mentioned, the server file to client. And of course, you can package them for mobile devices inside your application package. This is the recommended way. We're going to also discuss them, this method, in the performance improvement later on. Next thing you need to do, if you have a desktop Windows application, a RIA application, and you use third-party assemblies, .NET assemblies, which are not installed on the machine. So if you're using Windows assemblies, then you're fine. But if you're using third-party vendors like DevExpress and so on, they are not usually installed on your client machine. So you should either install them before starting your application, or copy them to the client cache using server file to client. Now, once you install, you run it once, then everything is okay. So some of the paradigm is which you can use in this case is just run the entire application once connected to the server, and then you're fine. But if you don't want to do it, then you should copy them in advance. And the next thing you need to handle, of course, is the data. Long time ago, we introduced a local database, which is a new local database gateway, which is actually an SQLite database. And this database is stored on the client machine. And we have this implementation on RIA desktop and also on all the mobile platform. And it is also encrypted. You can encrypt it if you want to. And all the local data should be stored in this database, the local database. Now, this database is accessible by offline and also by non-offline programs. So you can also use it in a non-offline programs, but usually you would use them in offline programs. And there is also a new function called data view to data source, which helps you synchronize the data from the server to the client. We are going to discuss it later on. Some limitation for offline tasks. We don't support the tree control and frames in offline tasks. Server data sources, operation, and expressions also cannot be used, of course, because as I've mentioned, offline tasks cannot and will not access the server. So in case you will have server data source or operation or expression in a server in an offline task, you will get a checker error. Now, if you run checker, then of course you will get an error on those things. One more thing is that the task prefix in offline task is also a local client-side handler, unlike non-offline tasks. Now, similar to that limitation, only offline programs can be used in offline program subform, and offline programs cannot be used in non-offline program subforms. And offline tasks can only have offline rich client subtasks. So these are some of most of the limitations of offline tasks. Moving onwards, some other information about offline programs. Offline programs cannot access the server as I mentioned, but sometimes you need to call a non-offline program. For example, to synchronize data from the server, you need server access. Now, this is done by raising an event in the offline program, and you will have a handler in the main program that handles this event. Now, in the main program, you can write whatever you want. So usually, let's say for the sync process, if you want to start it manually, then in the offline program, you will raise event of do sync. In the main program, you will have a handler for this event, which we call the non-offline program of the sync program. So you can actually, by using this technique, call from offline to non-offline programs. Now, when you start the application without connection to the server, then the application will start as offline. But by default, the application will always try to connect to the server in order to download updated metadata and so on. And this is the recommended way. If the application can access the server, it will start and access the server, and there is a timeout for it. And then if it will fail, it will start an offline. This is the recommended way. But if your application is do not require to access the server on startup, say you are going to do the sync only once in a week and you don't want to waste even 1 second on startup, then you have a special flag in the execution property called connect on startup, and you can set it to no. In this way, there is no sync, there is no access to the server even on startup. But again, I recommend to try to connect to the server on startup in order to sync everything as I mentioned. Now, for the main program execution, if your application is connected to the database, to the server, then the main program will be executed both on the server and on the client, and a context will be opened on the server. This means that for the next calls to the server, if you're calling a sync programs, then there is already a context there, and the performance will be better. If there is no connection on startup, either by this flag that I've mentioned or because the server is not available, then the main program will be executed only on the client side, and there will be no context open on the server. And once you would try to access the server, if it is available, then the main program will be copied there, and the context will be opened on the server. And from that moment, there is actually server access. Now let's talk about server access and recovery. So by default, when you run your application and you try to access the server, even on a regular RIA application, you will get a message box saying the server is not available, and the user can choose to abort or try or cancel. So this is the default behavior also when you start the application with an offline program and then you try to contact the server. Now, you can disable this message box, so the user will not see it, by using a function called client statistics set, and it has the parameter of enable communication dialog. This is currently the only string parameter there, and you set it to false. And by doing so, if the client will try to connect the server and it will fail because there is no network or the server is not available, then the end user will not see anything. In this case, it's the developer responsibility to handle it, and we'll talk about it in a second. But from the application point of view, all the non-offline programs that are currently running will be terminated. So if you are currently started the application in offline program called a non-offline program, which is now trying to call a third non-offline program, and there is a problem, then all the non-offline programs will be closed, and actually the flow will continue with the offline program, starting from the next execution, the next flow in the logic after the call to the server. So usually you will have an offline program doing some calls to a server and then continue from there. So from the end user point of view, nothing happens. He doesn't know that there is a failure to call the server, and you, the developer, should tell him, either tell him that there is a problem or actually do something else. And for that, we actually have two things you can use. One is an event, unavailable server. This event is automatically raised when you try to contact the server and it is not available. So you can write generic logic there, for example, show a nicer message box to the user, or keep track of this in a log file or whatever you want. And the other thing you can use is a function, server last access status function. But if there is a connection to the server, it will return 0. If there was a problem and there are some kind of problems, you will get a different error code. Now, the function can be used as part of your logic. So you can, for example, have a handler which calls a sync program, and if it fails, you can verify it with the function and either show a message to the user, or, for example, store the data in a local database, or, for example, do some alternate code. So the function lets you handle problems with communication as part of your flow, and the event is more generic thing. Now, the last element in an offline application is the local storage, as I mentioned. So we have a local database in the DBMS, and it has some limitations, such as it can only be used in rich client tasks. It behaves as a physical transaction, and you cannot mix server data sources and local data sources. It also has some limitations in SQL aspect, but basically it is an SQLite file, and you can also copy it between the server and the client. Now, unlike server database, if you do any changes in this database, in a server database, then usually you will do it once by the admin. Now, when we talk about local data sources, and let's say you have hundreds of mobile devices having local data sources, and you need to change this local database data source structure, then you as a developer cannot really handle those kind of changes. So we do it automatically. So whenever the application starts and it is connected to the server, then first of all, the server checks if the structure on the client is the same as the structure on the server, actually on the ECF file, inside the ECF file, not on the server. And if there was a change in the ECF compared to the local storage, then automatically the client will convert the existing data source and apply the new changes to them. So if you add a field, delete a field, or even modify a field, then this conversion will be done automatically by the client on startup. So you as a developer don't need to handle those scenarios. Now, of course, that if you do something that invalidates the data, for example, change a numeric field to a string or vice versa, then this data in this column will be lost. So it's not a good thing to do it. So usually you will add new fields or delete fields, but you will not change the characteristic of the fields. Now, the identification of data sources is done by an ISN. So for example, if you want to rename a data source, then still the client will see the original data source and not the renamed one. So it's usually if you want to rename something, just duplicate it and not rename it. Okay, so these are actually the characteristics of an offline program. If you have any question regarding offline as a concept, again, feel free to ask them in the chat menu. And if not, we are going to continue with data synchronization methodology, which is also a very, very important thing. Okay, so for dataset-based synchronization mechanism, this is something you need to handle. And in order to do the synchronization, actually, you need to identify all the records that actually were modified since the last time you did synchronization. And to do so, you need to add to any data source that you need to synchronize it, either from the server to the client or from the client to the server, to add a new column, which is a UTC, like a numeric field or a string field, which is save a UTC of last modified timestamp, and you are going to update it on every update that is done. So in this case, we will know when each record is updated and then only copy the newest records to the client or to the server. Now, for deleted record, actually there are two conventions. One is to use logical delete. Logical delete means that the records are never really deleted. Instead, you are going to add a new column to identify deleted records. So for every column that is actually the user wants to delete it, you will mark this column, which is usually a logical field, as deleted. And in all your programs, you are going to filter out, to range out the deleted records. This means that from the synchronization point of view, you don't need to do anything, because once you use a deleted record, then it's like updating any other column. So the record was just changed. There is last modified timestamp which was changed, and that's it. You just need to handle it in your application to do range on non-deleted records. Now, if you have tons of the records which you are going to delete, then the other way to use it is to have a separate data source with the IDs of all the records that you deleted. But this is a bit more complex, and you're going to handle synchronization also for this data source and then delete the records from the client. So usually I don't recommend going on this direction. Now, the next thing you need to do is to have an additional data source, usually with one field and one record, which stores the timestamp of the last synchronization. So whenever you do a synchronization, then you're going to update these timestamps. You might need two fields. One is for synchronization from the server to the client. The other is from the client to the server. Depends on your application. So if you are going to do it all at once, you can use one field. If you're going to do it with different periods, then you can do it with two fields. Now, usually you will have a synchronization management program, and this program actually will do three things. It will read the last synchronization timestamp from this local data source. It will call synchronization programs, which we are going to discuss in a second. And then, if everything went okay, it will update the last synchronization with the current date and time, or actually with the time, the date and time when you started the synchronization programs. So if new records were added in the meanwhile, they will not be also synchronized again. And for synchronization programs, usually you have two types of programs. One is to synchronize data from the server to the client, and another one from the client to the server. And for deleted records, as I've mentioned, depends on your method of deletion. If you're using a separate data source, you also need to delete to handle this one. Now, if we'll just look at an application and we're going to look at a sample synchronization manager program, then this is a rich client, non-interactive, non-offline program because it needs to access the server. And usually it will handle everything. It can handle images using server file to client. Usually it will not do it. Usually server, the images and resources will be synchronized once in the init, because the synchronization manager can be called on different times, and you don't need to handle image synchronization each time. So usually you will not see those. You will see a task to fetch the last synchronization date. You will see call to the synchronized programs, and you will see a task to update the last sync date after everything is completed successfully. So this is a demonstration of, in this case, server to client. Same goes for the client to the server. And again, you might have several synchronization manager program. Depend on timing. You might want to call the synchronization of, let's say, the orders each time after an order is added, and to synchronize, let's say, cities once in a week. So everything depends on your data and what you're trying to sync. Now, as per the synchronization program, and I'm saying it at first, this slide is not correct, do not use it. But once we said that the best synchronization methodology is first to define a rich client program with a server, let's say from server to client, server main data source, and do a range according to the last modified timestamp. This is correct. Then for each record, you're going to call a subtask or an offline program to write the data. This was once the recommendation. Again, this is not efficient. Don't do it. I still see some applications that use synchronization that way, and this is not efficient at all. So do not use this convention unless you have only one or two records, and even in this case, I wouldn't recommend doing it. Now, the correct way is actually, again, to define the rich client program, same as before. This program will have an end task condition of yes and a valid condition before. So this means it doesn't actually scan all the records. It just uses the range on the records as a range definition, but it does not process all the records. And in the task suffix, evaluate the data view to data source function. This function will actually take the data source range and declaration defined in the main data source of the task, create all the records, and move them to the client side. Same goes from the client to the server. And just to emphasize how important is the difference between them, let's just use an example. So I have here, let's delete the local table, and I'll show you that the local table is empty. So I have here a bad example of also deleting the table just to make sure, calling a synchronization program which has the range which is okay. In this case, I'm only ranging 50 records. Usually, you will also do a range on last modified timestamp, but in my case, I've removed it so to always do the synchronization. And in this case, I have 50 records which I'm going to synchronize to the client using calling a subtask, which will have a link right to the client local database. As I mentioned, you cannot use in the same task both server and local. So in this convention, you need to do different tasks. And if you will run this program, which synchronizes 50 records, then you will see it takes about usually 3.3 seconds for 50 records. And in this case, I'm not even having communication because it's from my PC to my PC, only from a MySQL to local SQLite database. So it takes 3 seconds. Now, if you are going to remove, to have the same concept, but in the task itself, have end task condition of yes and evaluate before, still thinking on those 50 records, and that's it. In the logic, I have the task suffix which uses the data view to data source function. So even my task is simpler, I don't have the redundant subtask. And let's run this one. So it takes 0.2 seconds, and you can of course see that the records are there. Now, if we are going to do the same in this case, but I will remove the range completely, so I'm syncing all my records and not just 50. So it takes 0.3 seconds compared to 3 seconds in the initial demonstration. And let's just browse the data source and see that I have 1,000 records in 0.3 seconds instead of 3 seconds, okay? So the synchronization again, and here there is no communication, but usually you will not synchronize 1,000 records, and we are going to discuss it later on. For the server to read the data sources and copy them to the client and have them in the client, it shouldn't take much time. If the synchronization process takes you a lot of time, something is not written good there, okay? So be aware of it. And again, I'm talking about a Sing application that had about 30 seconds and even more of synchronization and reduced than less than a second. Just by having a bad methodology of synchronization, they either synchronized all the records or didn't use this convention. So be aware of it. Synchronization should be very fast. And since it is fast, then usually you can call it after you add the data to the local. So you usually will work on a local data source, keep all data there. And after the order, let's say, is finished, you can call the synchronization program. If it works and there is connection to the database, great. If not, don't do anything. You will think in next time, and so on. So this way you will have the most updated data in the server in case the application has server access, because it is working fast. Now, in case you have a large database, let's say with tens of megabytes, which is very huge, you don't usually want to use the function for it because you're going to send it as records, as XML, which is not that efficient. But you can also, since we are using SQLite database on the local machine, and we already support SQLite on the server machines, so what you can do is define a database on the local as a local database with the same name and convention as a server SQLite, fill the server data, and just copy this file as a whole file to the client. Now, it is useful in some cases let's say you have lots of cities, countries, and so on, and you prepare a database in advance so you can just copy it to the client side. You can also package it in the application. We're going to discuss it later on. So if you have lots of data, which is, let's say, static data, then you can create an SQLite file on the server and just use server file to client if the file is not available on the client machine. So for the first time, you will copy this file to the client, and then use the synchronization programs to copy the delta files, the delta records. So this is also something you can use. Now it has more detailed information in the help. I'll show you later on where it is fully detailed, so you can, if you need it, you can use it. Any questions before we are continuing to the talking about performance improvements, which is also related to offline development? Okay. So let's continue to talk about performance improvement in an aspect of offline. So first of all, when you create a new application, you usually have the end user functionality component, and usually you have the default menu. Now, if we are talking about mobile devices, then the end user functionality component is actually not used there, and also the default menu is not used, since there is no MDI, which is this menu is usually assigned to. But still, since they are defined in the application, then in order to support offline, then they will be copied to the client side. At least the menu will be copied, the end user functionality will be accessed to be scanned if there are offline programs in it. So if you have an application which is fully, let's say, mobile application, and you don't need them, then it's best to remove them, even if you don't use them. Okay, so it will, one less menu to copy to the client, one less component to scan. It will improve the upload time, the initial and startup time, sorry. Now, I've already mentioned the server access status function, and if it's success, it will return 0. So let's say you have several calls to server access, for example, to retrieve several files one after the other, or to call several sync programs, and you're doing them from an offline program. Usually, you would condition the second and third one with this condition. So if the first access failed, there is no point on spending 2 seconds on the second access, because for sure it will fail, and also on the third access, because it will surely fail. So it is best practice if you have several access to the server from an offline program, just condition the second, third, and first with the same expression. So if the first one fails, no need to do all the other ones, just to save the timeout time. And of course, you can also play with the timeout and reduce it if you want to. Now, also avoid record level transaction in non-interactive client processes. Okay, if you have non-interactive task which runs on client record and do something, then you don't want to open a transaction for each one of them. Especially if you have server data source there, you don't want to go to the server for each record. So it's best practice to use task level transactions in these cases. Next thing is to use server file client on a folder or using a wildcard, and this is very, very, very important. Now, the server file to client, the way it behaves, it first take a list of the files you want to send, see the timestamp, and let's say from the server to the client, then the client side will check the timestamp of the file in his cache and tell it, do one request to tell the server, this is my timestamp, do you have any update? And if there is an update, then the client will ask for the update. If there is no update, then there is no, the file will not be retrieved again to the client. Now, if you have, for example, 100 files you need to synchronize, and you're going to use server file to client for each file one after the other, then for each file there will be a request from the client to the server telling the server, this is my timestamp, do you have an update? And let's say nothing was updated, So you will have 100 requests for each one for each file. Now, if you will use a wildcard or a folder, you will have only one request telling the server, I have a folder with 100 files with those timestamps, send me the new ones. So the good scenario, you will have only one request, and if this is the first execution, you will still have other requests to fetch the files. But for the second execution onwards, you will see only one request or very few requests to get only the updated files. If you use one file separately, you will have lots of requests causing a very slow load time. So be aware of it. Now, some more things. In Android and iOS, and also on the new Windows 10 mobile devices, which we are supporting in 3.2, then you can use you can package the images and resources as part of the APK or RPA file. So when you create your own custom application, there is an asset folder there, and you can just put all the images in this assets folder. So they will be part of the package which you upload to the store or install it on your devices. And when you install the application on the devices, then all the images and actually local storage or everything you put there is actually now will be copied to the cache as if you copied it yourself. So this means that even the first download time, you can save it because you will not really actually do it because the files are images. Now, still you would want to use server file to client on the folder or wildcard, as I mentioned before, for two reasons. First of all, you don't want to create a new package anytime you update a resource file like an image. So you would want to use the function to download the new images. And second of all, once you do it, then the client will know and will load into memory all the timestamps of all the images. So if this image is used in a non-offline program later on, then the client will know that it already has the latest copy, so it will not ask for the server for this image. So it will also improve performance of non-offline programs. Okay, so it is good practice to package images in the assets folder and still use server file to client to copy the new files or modified and to improve performance of non-offline programs later on. Next thing is to reduce the image size and resolution. Now, this is also very important, especially the resolution part. Sometimes you will get from a designer a 5K image, which you say, okay, it's 5 kilobytes, then this is okay, but the resolution will be 2000 by 2000 because this is how the designers work, and it will be even for an image which should be displayed on a button or an icon or something small. Now, of course, you don't need your one of your icons in the screen to have 2000 by 2000 pixels. It is good enough to have them by 100 by 100 pixels. And when an image, it's important to understand that when an image is used, especially on mobile devices, but also on desktop, but on mobile, which they are slower than desktop devices, it is important to understand that first, the image is loaded into the memory according to the original resolution. So if you have 2000 by 2000, then it will be loaded into memory, consuming lots of memory. And then internally, we are going to reduce it to the size of your icon or whenever you use it. So by having an image with high resolution, and especially in a table control, which is the worst thing you can do, you will have lots of memory usage, poor performance, and the image does not really need it. So be aware of it. It's very, very important. So the resolution matters, not just the file size. And now on Android, it is also best practice to avoid transparent on table control and controls attached to a table. And this is because Android has a built-in mechanism to better improve the performance of table controls by using cache of cells. And if you use transparent, then this mechanism is disabled by default on Android. So you can use transparency, it works fine, but if you remove it, you will gain the benefit of Android caching on table cells, which is much smoother than without it. And also for alternate table color, again, the same concept. Once you use it, then the internal caching is actually not used because it cannot reuse the cell design, and the flow will be less smooth. Of course, on the current devices, which are much faster than the old ones, I'm not sure you will notice it, but be aware of it. And last thing about performance improvement techniques is about your data. And this is also, as I mentioned, very important. First of all, to use data view to data source, as you saw, there is a big difference whether you synchronize data using this function or whether you're going to synchronize data using call links or calling to something else. So this is very, very important. Next thing that you can consider is to copy database to your device using server file to client. And again, it depends on the amount of records. If you have, let's say, 10, 20, 100 records, usually it will be very fast to copy them using the data view to data source, and that's it. Remember, it's only doing it for the first time. Later on, you will do data with synchronization. So I'm not sure it's worth investing in copying the entire database or a subset of it as a file. But if you want to copy a lot of megabytes of data to the client side, then you can consider it. And you can also consider preparing it in advance. So you will not need to copy it from your Oracle or MySQL data to an SQLite and then copy it. Just prepare the SQLite in advance and then copy this file, or even package it in your application. If this file is common to all the users, you can package this file into your database. So you have here all the techniques that are used to improve performance. And again, it can improve your application synchronization from minutes to seconds. And so this is very important. And in fact, if you see that your application is not working fast, then you should consider either reviewing the synchronization or involving someone else to have a look at it, because from our experience, this process is very fast if it's correctly written. So just to summarize all of those issues, when you develop an application, it can be a desktop application, but usually you would have it for a mobile application. The first program, I didn't mention it, but the first program usually will be in offline. It is best practice that most of the programs will be offline, if possible. You can do a hybrid of offline programs, which sometimes call a non-offline programs. For example, if you have a banking application, so you want the first program to be offline, so your application will start, then you might show him some details which are allowed to be stored locally. And then after the logon, you connect to the server to show real data, live data, without storing to the client. So this is also a possibility. So use offline programs as much as possible. They are faster than using non-offline programs. Use local data for partial server data and also for new data on the client. And use short synchronization programs, okay? So then you can call them either after you finish adding data or manually once in a period, depending on your data. Properly handle network connection errors. I wouldn't recommend keeping the behavior as default, which the end user is seen with an error telling him, do you wish to retry? It's best to use to write your own logic, either silently try to connect again, or doing the synchronization once in a while, or even showing the user some other message saying, try to sync again later on. Currently, you're not connected to the server. Please check your status, and so on. And of course, implement everything that I've mentioned in the performance improvement slides, because it can really improve the performance of your application. Any questions? If there are any questions, feel free to write them in the chat menu. Okay, now, since I see that there are no questions, then Everything that I've mentioned here is also mentioned. We have 3 concept papers which we have added. They are part of the help. You can see them as part of the help, also as a separate PDFs. And you can see all the information about synchronization from the server to the client and vice versa. All the information about performance, and also enhanced information about packaging resource files, because there are some conventions there and some nuances that you need to take care of. So be aware that we have those things, just read them. And after seeing this introduction to offline development, then of course you'll understand and will know how to implement them. So in case there are no questions, then thank you very much for attending this session, and good luck with developing your offline applications. If there are any questions, then still feel free to ask them. Thank you.